What I'd like to talk about today is section 7.2 day 2, which is about the disk and washer method. We started the disk method on 7.2 day 1, and we're going to look at that a little bit and then continue on from that. So the disk method, when we looked at it, it deals with having a horizontal axis of revolution if we are spinning around the x-axis, and it has a vertical axis of revolution if we're spinning around the y-axis. So here it has us spinning around the x-axis, so up here is a very little change in x, so everything about this should be in terms of x. Over here, when we spin around the y-axis, this thickness here on our representative rectangle is a very small amount y, so everything about this problem is in terms of y. So here, what we talked about in class is we're stacking circles. So from here, there'd be a circle, there's its radius, and the other radius would be here, creating a circle to make a three-dimensional object. On this one, here's our biggest radius, and over here would be a matching radius, and when we spin that radius, it would make a circle, and then we're stacking circles one on top of the next. So our first example says let's revolve around a line that is not one of the axes. So in this particular problem, we're going to spin this around this line right here, which is the line y equals 1. So one of the things that we need to take into consideration is whether or not there is a hole between the region that we have. So here's our region. Is there a hole anywhere between that and the pink line I've drawn? So this has no hole. And because it has no hole, it means that I'm going to do the disk method. So the disk method is very similar to what we learned the other day. So we're going to have pi and then our radius squared. This has a little tiny thickness x, so it's in terms of x. And then we need our radius in terms of x also. And nicely, that's in terms of x. It says y equals x stuff, and this one says y equals x stuff. So we're going to take the top, which is the parabola, minus the bottom, which is the line. So for our radius, we're going to say that we have 2 minus x squared minus 1. And again, this is the function that's on the top. That is the function that's on the bottom. So we end up getting 1 minus x squared, quantity squared. Now, if we're going to work this by hand, what we would do is we have to expand this. So if I expand, I have 1 squared is 1. I multiply those two together and double it, and then I square that and I get x to the 4th. We're going to take this from the left, -1, to the right, 1. So again, I want you to practice working this out by hand so that you're ready for the AB exam in May. If you do it correctly, your answer will be 3.351. So this is example 1. And again, this is the disk method. Now the difference between disk and washer is that with the washer method, there's going to be a hole between the shape that we're looking at and rotating and the axis about which we are rotating. So this one asks us to rotate around the x-axis. So I look here, I'm rotating around the x-axis. If I look at the shape that they're asking me to spin, it's here. And I see that there's lots of stuff here where the function is not touching the axis. So this one is said to have a hole. Since it has a hole, we need to account for that. So what's going to happen when we set up this problem is we're going to have two radii. To do your radii, you always need to touch the axis about which you're spinning. So for each radius, I have to touch this. So I have a radius that goes from the x-axis, which I'm spinning about, to the function y equals x. And then I have a smaller radius that starts on the axis I'm spinning about and goes here to y equals x squared. So the setup for this is that you're supposed to take the big radius squared minus the little radius squared. So for us, our big radius is going to be the top x minus the bottom 0, or simply x. And our little radius is going to be the function that's closer to the x-axis minus that x-axis number. And so we get x squared. So our setup for this one is going to be our big radius squared, so x squared in terms of x, minus, and then pi little radius squared in terms of x. And our graph is starting, if we find the points of intersection, that point of intersection there is 0, 0, and our point of intersection up there is 1, 1. So we're going from that x value to that x value. So for both of them, 0 to 1 and 0 to 1. So if you wanted, since they're both going from 0 to 1, you could actually put x squared minus x to the 4th with just 1 pi outside and integrate this in terms of x. Remember that we're practicing doing this by hand, so you should practice that, and if you do it correctly, your answer should be 0.419. Okay, last part of this, doing several different things with this feasible region. So we have y equals the square root of x, y equals 0, which is the x-axis, and x equals 3. So this thing's going to end here. So I'm looking at this. This one, they do ask us in part A, it says let's spin this around the x-axis. So spinning around the x-axis, if we look, we'd get this reflected image down here. Okay, our representative rectangle. Now the thing to notice is that there is no hole between this shape and this axis about which we're spinning. Since there's no hole, this is going to be the disk method. And the disk method ends up being, I think, easier than the washer method because the washer method has 2 radii and the disk method only has 1. So our radius here is going to be the top function minus the bottom. And we are in terms of x. So when we set this up, the function on the top in terms of x is root x, and on the bottom is 0. We're doing pi radius squared. And we're starting at this x value, which is x equals 0, and we're ending at this x value, which is 3. So we're going to go from 0 to 3. So what we're actually integrating is x in terms of x. So if you work this out by hand to practice, you, in the end, if you're right, should get the answer 14.137. In this example, we're looking at the same original shape, but this one wants us to spin around the y-axis. So if we look between this shape and the thing we're spinning about, this doesn't have any of the shaded area in it. So this thing has a hole. And because it has a hole, it means that we are going to do the washer method. The washer method needs a big radius, you're going to square it, minus a little radius, and you're going to square it. The other thing to keep in mind, since we're going around the y-axis, unfortunately, we're going to have to be in terms of y. So if we're in terms of y, we have the function y equals root x. We're not allowed to use that in this problem. We have to use y squared equals x. So we're going to use that. What we also know is that we're going around the line y equals x, which is x equals 0. And we have that line here, which is x equals 3. So we need to come up with 2 radii. So each radii has to touch the axis we're spinning about and go to one of the 2 functions. This one's going to go to 3. That's going to be my big radius. So my big radius is 3 minus 0, or the right minus the left. So that's 3. My little radius is going to start on the axis I'm spinning about and go to the function I haven't yet used. So my little radius is going to also be right minus left. The one on the right is y squared, and the one on the left is 0. So my little radius is y squared. So the setup then for doing this integration is that we're going to do pi big radius squared in terms of y minus pi little radius squared in terms of y. So my big radius is 3. My little radius is y squared. If you wanted, you could put them together in the same one. We'd have pi 81 minus y to the 4th in terms of y. The only reason you're allowed to put them together is because they're going to have the same numbers on the integral. So here's what we need to figure out. What is the lowest y value and what is the tallest y value? So here my y value is 0. When x is 3, my y value is root 3. So up there, that's the square root of 3. So we're starting at a bottom of 0 and ending at root 3, starting at a bottom of 0 and ending at root 3. And again, the only reason I'm allowed to put 81 and y to the 4th together in a single integral is because they're both multiplied by pi, and they both are going from 0 to root 3. So for practice, you should do this by hand, and if you do it correctly, the answer is 39.178. Okay, spinning around the line x equals 3. So again, this line right here is where our area is stopping, and they're asking us to take this and to spin it around this line. So if we spin that region around this, it's going to go out here to 6. It'll look like that. Since I'm spinning around this line that's parallel to the y-axis, what's going to happen is that I am going to need to be in terms of y because my radius needs to be perpendicular. When you look here, this area and this pink line meet. There is no hole anywhere here. Because there is no hole, this is disk method. And disk method means that there is only one radius. So our radius needs to touch this and the function over here. We're going to be in terms of y. So before we were given y is equal to root x, not allowed to use it. I want y squared is equal to x. I'm also going to deal with x is 3, and I'm going to deal with just those 2. So this one is on the right, and this one is on the left. So my radius is going to be the function on the right minus the function on the left. Since I only have one radius, my setup is pi radius squared, we're in terms of y. So 3 minus y squared, so notice in terms of y. And then we want to go from the bottommost y, which last problem, B, part B, we said was a y of 0. And at the top was a y of y equal to the square root of 3. So here we're going to go from 0 to the square root of 3. Work this by hand to practice. And if you do it correctly, 26.119 should be your answer. Final example. This one is having us take the region that stops here at x equals 3, and they want us to spin around y equals 6. Sorry, x equals 6. So this is x equals 6. If we notice, really important to notice, that there is a hole between the shape and this line that we're spinning about. This is a hole. Because we have a hole, and I see that you can't see that, so I'll darken it in. Because we have a hole, we're going to be doing what is called the washer method. So the washer method says we're going to have pi integrate big R squared minus pi integrate little r squared. We are going around something parallel to the y-axis, so we are again going to be in terms of y. So for my big radius has to touch the thing I'm spinning about and the furthest function away from it. So my big R is going to be 6 minus, and the one furthest away from it is y is equal to square root x, which became y squared equals x. Have to be in terms of y, so I want 6 minus y squared. My little radius, I'm going to touch the thing I'm spinning about and go to the function of the two that's closest, and that's 3. So I'm going to get 6 minus 3, which equals 3. So setting this up, pi quantity 6 minus y squared in terms of y, and we're going to integrate, minus pi integration of 3 squared. Our bottommost y from the last couple of problems was 0. Our topmost y was root 3. Keep in mind when you do this by hand, I lost my square here, didn't I? This has to be squared. So when you do this by hand, you would have to square the binomial. You get 36 when you square that. Multiply those two and double it, so negative 12y squared. Square that, it's going to become a positive dy, and then minus pi integrate 9, both of these from 0 to root 3. So when you're done with this, if you practice doing it by hand, at least make sure you do it in your homework that way, your final answer should end up being 91.415.